Welcome to problem set 4 in arithmetic progressions. In this set, we will be looking at problems dealing with the sum of n terms of an arithmetic progression. Problem 1 states, find S7 if A is equal to 20 and B is equal to 3. Now for such problems, all that you need to know is the formula for Sn. And if you know that, you can plug in the values of A, D and N, which here is equal to 7, in the formula and find the answer. So Sn is equal to n by 2 into 2a plus n minus 1 into d. And plugging in our values, we can write therefore S7 is equal to 7 upon 2 into 2 into 20 plus 7 minus 1 into 3. Solving this, we get therefore S7 is equal to 7 upon 2 into 40 plus 6 into 3, which is equal to 7 upon 2 into 58. And 2 29s are 58 and 7 29s are 203. Therefore, S7 is equal to 203. So simply by knowing the formula for Sn and plugging in the given values, we have found our answer. S7 is equal to 203. This kind of problem should present no difficulties to you. Let's move on. Problem 2 states, find the sum of the first n even natural numbers. Hence, find 2 plus 4 plus 6 plus and so on up to plus 100. Now in your examination, when you see this word hence find, what they mean is you need to use the result of the first part of the question to find the solution of the second part of the question. So I repeat, when you see the word hence in a question, then they are saying that you need to use the result of the first part to find the answer to the second part of the question. So first we need to find a formula for the sum of the first n even natural numbers. Given n even natural numbers, what can you say about the first term, the common difference? The first term a is equal to 2 and the common difference b is also equal to 2. Now here you need to be careful because many students will make mistakes in writing the first term and the common difference. A lot of students write a is equal to 0 because they don't read natural numbers and they don't realize that 0 is a whole number, not a natural number. So the first even natural number is 2, not 0. And the second mistake that students commonly make is that they will write d is equal to 1. Now for natural numbers, yes, d is equal to 1. But here we are given even natural numbers. And for even and odd numbers, d is equal to 2. So beware of these potential mistakes in your examination and write the first term and the common difference correctly. Now we can write the formula for Sn and substitute our values of a and d into it. So Sn is equal to n by 2 into 2a plus n minus 1 into d. Therefore, Sn is equal to n by 2 into 2 into 2 plus n minus 1 into 2. We have substituted a is equal to 2 and d is equal to 2. And we can simplify this to write Sn is equal to n by 2 into 4 plus 2n minus 2, which gives us equal to n by 2 into 2n plus 2. And we can cancel out the 2's from the numerator and the denominator. Therefore, Sn is equal to n into n plus 1. Now we have a formula for Sn only in terms of n. We have got rid of a and we have got rid of d. So now we can move on to the second part of the problem. And if you remember, I said we need to use this formula of Sn to solve the second part of the problem. So we say for the given sequence 2, 4, 6 and so on up to 100, what is a and what is b? A is equal to 2. D is also equal to 2. You can see the difference between any two consecutive terms is equal to 2. And what is the last term Tn? Tn is equal to 100. Now if we know A, we know D and we know Tn, can we find what is n so that we can substitute it in our formula for Sn? Yes, we use the formula for Tn. Tn is equal to A plus n minus 1 into D. So we know Tn, we know A and we know D. Plugging those values in, we can solve for n. Therefore, 100 is equal to 2 plus n minus 1 into 2. Therefore, n is equal to 50. Now, this is also a place where many students will go wrong. They will just look at the last term 100 and they by mistake will write n is equal to 100. Tn is equal to 100. So make sure you don't confuse Tn and n. Tn is the last term of the sequence. N is the number of terms in the sequence. So don't make the mistake of writing n is equal to 100. We have just found that n is equal to 50. Now that we know the value of n, we can just substitute it in the formula that we got for Sn. So let's call that equation 1, and we can say substituting n equal to 50 in equation 1, we get Sn is equal to 50 into 50 plus 1. Therefore, Sn is equal to 2550. So we have found the sum for the second part of the question. Therefore, 2 plus 4 plus 6 plus and so on up to plus 100 is equal to 2550. So I hope you get how to solve this question. You have to be very careful when you're writing the first term and the common difference and the last term, and don't get confused between n and tn. And finally, remember, when you see the word hence, you have to use the result that you find in the first part in order to solve the second part. So with this, let's move on to problem number 3. The sum of the first 11 terms of an AP is 66. Find the sixth term. Now at first glance, it seems that there isn't enough information to solve this problem. But when you look that they have asked you to find an odd number of terms of an AP, and the sixth term is the middle term of 11. So if you have 11 terms, then the sixth term is right in the middle. There are 5 terms before it, 5 terms after it. Now this is not a coincidence, because if you remember how we name the odd terms of an AP, we start with the middle term and call it A. And then as we go higher, we add the common difference B, and as we go lower, we subtract the common difference B. So we can start by saying, given S11 is equal to 66, and we want to find T6, the sixth term. So we say let T6 equal to A. So what will the other terms be? If the common difference is equal to D, then the higher terms will be A plus B, A plus 2D and so on, and the lower terms will be A minus D, A minus 2D, A minus 3D and so on. Therefore, T1 is equal to A minus 5D. Now, how did we get the minus 5? We get it from the suffixes. From T6 to T1, 6 minus 1 is equal to 5. So we get T1 is equal to A minus 5D. Similarly, we can write T2 is equal to A minus 4D, T3 is equal to A minus 3D and so on. And the last 3 terms we can write, they will be the mirror images of these 3 terms. Instead of minus D, you will put plus signs there. So T9 is equal to A plus 3D, T10 is equal to A plus 4D, and T11 is equal to A plus 5D. Now when you add up all these terms, do you remember what happens? All the D's get cancelled out. So when you add all the terms, we get S11, which is the sum of the 11 terms, will equal to 11A. Why 11A? Because there are 11 terms. So now we have 2 values for S11. We were given S11 is equal to 66. We'll call that equation 1. And now we have found S11 is equal to 11A. That we'll call equation 2. So equating these 2 values, equation 1 and equation 2, we get 11A is equal to 66. Therefore, A is equal to 6. And this is what we were asked to find. So T6 is also equal to 6. And we have found the sixth term of the arithmetic progression is equal to 6. So when you see such problems, it is important that you remember the naming system that I had taught you. Call the middle term A, and then you name the higher terms A plus D, A plus 2D, and the lower terms A minus D, A minus 2D, and so on. So that when you add them all up, all the D terms will get cancelled out, and you can find the value of A, which will be the middle term. So with this, I'm going to end this problem set. Thank you for watching, and I will see you in the next video.